Physical properties of engineering materials are critical characteristics that determine their suitability for various applications. These properties include melting freezing point, boiling point, density, linear coefficient of expansion, and thermal conductivity. A. The melting or freezing point. The melting or freezing point of a pure metal is defined as the temperature at which the solid and liquid phases can exist in stable equilibrium. When a metal is heated to its melting point, the liquid phase appears, and with continued heat supply, the solid melts completely at a constant temperature. This property is vital in processes like casting and welding, where precise temperature control ensures material integrity. Impurities or alloying elements can lower the melting point, creating a range rather than a sharp transition, which is important in designing alloys for specific melting behaviors. B. Boiling point. The boiling point of a liquid is the temperature at which its vapor pressure equals 1 atmosphere. The boiling points of most metals, except mercury, are high. Notably, the boiling points of zinc, 907 degrees Celsius, and cadmium, 865 degrees Celsius, are sufficiently low, allowing recovery of these metals from their ores through vaporization and condensation. High boiling points in metals like iron and tungsten make them suitable for high-temperature environments, for example, furnace linings. The low boiling points of zinc and cadmium enable efficient extraction via distillation, a key process in metallurgy. C. Density mass per unit volume is termed density, measured in kgm3 in the metric system. The low densities of aluminum and magnesium and their alloys make them particularly valuable in aeronautic and transportation fields. Density influences material selection for weight-sensitive applications. For instance, titanium, with a density of 4.5 g per cubic centimeter, balances strength and low weight, making it ideal for aerospace components. High-density metals like lead, 11.34 g per cubic centimeter, are used in radiation shielding. D. Linear coefficient of expansion. The linear coefficient of expansion of a solid is defined as the increase in length for each degree rise in temperature. These coefficients are important when metals are exposed to a considerable range of temperatures, as in engine pistons and other accurately fitting mechanisms. Differential expansion can cause thermal stress or misalignment in machinery. Materials with low coefficients, like Invar, a nickel-iron alloy, are used in precision instruments. Engineers must account for this property to ensure structural stability across temperature variations. E. Thermal conductivity. The thermal conductivity of a metal is defined as the number of kilojoules of heat that would flow per second through a specimen 1 square meter in cross-section and 1 meter in length when the temperature gradient is 1 degree Celsius. Silver and copper show the highest thermal conductivity